Right, so today we're going to have a look at relative frequency, expectation, and bias. So I'm just going to quickly let you have a chance to have a look at the questions, make some notes on it in your blue books, think about what you think the answers might be, and then when you're ready for me to go through it, hit play and I'll explain it to you. Okay, so question 1. A bias dice is rolled 100 times. Here are the results in the table, so you can see how many times each number appeared. We know the dice is biased, which means it's going to be weighted towards something in particular. So if you actually have a look at each of the frequencies, you can see there that number 3 has appeared an awful lot more than any of the others. So therefore it's biased towards number 3. Okay. And we're asked to estimate the probability of rolling a 1, an odd number, and a prime number. Okay, so what we're actually asked to do is calculate the experimental probability. That is the same as relative frequency, so it means exactly the same thing, but you'll often see in an exam that it's called relative frequency, and that can scare people and make them forget what it means, but it is just to calculate the probability from the experiment rather than what we'd class as theoretical probability, because we know that when you roll a dice, the probability of getting a 1 is usually 1 in 6, okay, but that's on a normal fair dice. So if we have a look at this first question here, so the probability of rolling a 1, now using correct probability notation, we would write the probability of rolling a 1, and you can see it appears 11 times out of the 100 rolls, okay, so it's 11 over 100, which you can leave it like that, or you can write it as a decimal. Either is fine. Fraction is usually a little bit tidier. Okay. The probability of rolling an odd number. Okay, so again, in terms of notation, it's the probability of an odd. Okay, and then our odd numbers are 1, 3, and 5. And therefore, what we need to do is combine them together. So the probability of a 1 was 11, added to the probability of a 3, which is 27, added to the probability of a 5, which is 17, all over 100, and then I can tidy that up and I end up with 55 over 100, which again, you want to either leave it in its simplest form, okay, which will give me 11 over 20, or you can leave it in a decimal if it is a nice number, so 0.55. Okay, and then our last one, the probability of rolling a prime number. Okay, so remember, a prime number is any number that has exactly 2 factors, 1 and itself. Therefore, 1 is not a prime number because it only has 1 factor. 2 is a prime number. 3 is a prime number. 4 isn't. 5 is, and 6 isn't. So again, we're just going to add those things together. So 14 added to the 27, added to the 17, all over 100, and that will give me 58 over 100. That will simplify down to 29 over 50, or 0.58. Okay, so that's how you do that one. In addition to that, though, what you can be aware of is the fact that you just need the general rule. Okay, so remember we said relative frequency is in fact just the experimental probability. Okay, so it means the same thing. And the actual rule for relative frequency, so this is a definite for your blue books. Okay, is the number of times the event occurs over the number of trials. Okay, so in question 1, obviously there were 100 trials, 100 rolls, and 1 came up 11. So that event came up 11 times, so it'd be 11 out of 100, 14 out of 100, 27 out of 100, and so on. Okay. Then, if we have a look at question 2, so question 2 wants us to calculate the probability, okay, the expectation of rolling a 1, okay, when we've got a biased dice. So we're told the probability of the biased dice is 0.24, and we're going to roll it 50 times. So this is where you need to understand the formula for expectation. Okay, so I'm going to pop that here for you. Again, can you pop this one in your blue books? So expectation is the probability of the event, in this case, rolling a 1, multiplied by the number of trials. So in this case, the 50 rolls that we're going to be rolling that dice. Okay, and therefore, our expectation on this one is going to be our probability, which was 0.24, multiplied by the number of trials, which was the 50 rolls, and therefore we expect to get a 1 12 times out of those 50 rolls. Okay, and then if we have a look at question 3, so here are the results of 60 dice rolls. Work out the relative frequencies of each score and then think about whether it is biased or not. Okay, so if we have a look, we know it's 60 rolls, so therefore the probability of getting a 1 is going to be 12 over 60. In its simplest form, that's 1/5. Okay, or we can write it as 0.2 if we want it as a decimal. Probability, or the relative frequency of getting a 2, is going to be 3 out of 60, which is the same as 1/20th, or as a decimal, 0.05. Number 3 is 9 out of 60, and when we simplify that one, we get 3 out of 20, as a decimal, 0.15. The relative frequency of a 4 is going to be 10 out of 60. That simplifies to 1/6. It's not a nice decimal, so I would prefer it left as a fraction, but it's 0.16 recurring on that one. Then we get to the relative frequency of 5, so that's going to be 14 out of 60. That's going to simplify down to 7 over 30. Again, it's much better as a fraction on this one because it comes out at 0.23 recurring. And then the last one is 12 out of 60, simplifying down to 1/5, okay, giving us a final decimal of 0.2. Now, all of these, remember, with probability should always add up to 1, so you can always double check that you've worked out your relative frequencies there. So that's part A. Part B, do you think the dice is fair or biased? Well, you can have a look at the data, okay, so the actual frequencies, but you can also think about the theoretical probability. So in theory, the probability of getting a 1 we know is 1/6, and therefore we expect to get a 1 1/6 of the time times by the 60 rolls. Therefore, I expect to get a 1 10 times. Now, the probability of getting a 2, in theory, would be 1/6 again. So actually, in theory, we expect them all to be around the 10 mark. Some of them are close, but if you think about it, the 2's only come up 3 times, so it doesn't really look like it's a fair dice. Okay, so it is likely to be a little bit biased. Okay, so you've got a worksheet now to have a go at, which involves relative frequency, expectation, and deciding whether something is fair or biased. So give it a go, and then let me know if you've got any questions.